Welcome to how to create a new custom creature in DAZ Studio, presented by Shaylin Hamar. I'm hosting today. My name is Paul Bussey, and this webinar is copyright 2018 Digital Art Live at Shaylin Hamar. So welcome everyone in the room. Please give Shaylin a warm welcome.
Thank you very much, Paul. As he said, I am Shaylin Hamar, and today we're going to talk about creating a custom creature in DAZ Studio. The bonus video covers more of the meshing parts of this, but I will be going over some of the workup here that you need to do in your modeling software. In this case, I have Blender. Now, you'll notice that I've modeled the gecko with its mouth open. You probably don't want the mouth open in your final version. So Blender has the option of creating what it calls shape keys, which many other programs call morph targets. You access these through the data panel, which looks like a triangle made of 3 connected dots here over on the right. And in the shape key, you hit plus once and it creates the basis. You don't want to edit that. Then you hit plus again, and however many times you need to create additional keys. My first key here is for closing the mouth. Generally, you're going to need to model a creature with the mouth open so that you can access the inside to get enough detail. But you can, before export, close it with a key. I have not done that in this project, but I will also be talking about ways to deal with that going forward. And I've created another key for closing the eye. This was modeled at a relatively lower poly count. It's about a 5,000 polygon creature. And you'll notice that there's a little clipping in the eyelid there. In this case, that's because the creature is meant to be seen at subdivision 1. If it's being seen at a distance where the lower polygon count won't show, then the clipping in the eye probably won't show either. And when it's subdivided, it will not be clipping with the eye closed. So the other thing that you need to do before export, you've got your creature modeled. It's in a relatively neutral position. You've got the mouth open, or you've morphed it closed, and you've got the eye open. Then you also need to create vertex groups, because this is how Blender generates the bones. So for example, each of these eyes, each of the eyeballs here, is a vertex group. The vertex groups panel is in the same place in Blender as the shape keys. It's in the data panel. You can see I've got quite a list here. Basically what you do is you select the part that you want to be in a particular group. I'm going to actually use face select, which is accessible down here on the bottom bar, because you can have some ambiguities and overlap that can cause problems in Blender if you assign vertex groups in vertex select rather than face select mode. So in face select mode, you select all of the faces you want as part of a particular group, and then you go to the vertex groups editor here, and you hit the plus sign, and it just calls it group there. Then you double click and give it a new group name, and then you hit assign to that new group. I'm not doing that because I've already got eye groups assigned here. Once you have a group for every place that you want to have a bone, then you'll be ready for export. Oh, one more note before I do that. I have a hip node here, and I have the body rigged forward from the hip and back from the hip. So instead of starting from the head and going 1, 2, 3, 4 backward from the head, I'm going to start from the hip and go 1, 2, 3, 4, and then the head. I didn't give it a separately rigged neck in this case because geckos have a very short neck. I didn't give it separately rigged toes either. That's more of a time issue, but also because geckos don't have the ability to move their toes really separate from one another. At least the leopard gecko that this is modeled on does not. So you assign your vertex groups, and you set them up forward and back from the hip node. On Genesis 8 female, who I've included for scale, the hip node is not actually a bone with weights on it. It's just a parent of all of the others. So from the hip, it goes pelvis and downward, and then abdomen and upward. So the center of the body's rigging is in this area on Genesis, and then it's in this area on the gecko. And of course, when you're rigging a different type of creature, you may choose to do that differently. When I rigged a snake, I rigged it from the center of the snake's body also, so that it was rigged forward and back from the middle. Are there any questions on the workup as we go so far? Hi, Mark.
Okay, any questions so far? And just as a check, anyone use Blender in the room already? So Max is asking, what is clipping and why do you need to make vertex groups first?
Clipping occurs when part of the body intersects inappropriately with another part of the body. So when I use the eye key and you can see the top of the eyelid has intersected with the lower part of the eyelid, that's called clipping. It is clipping with the other part of the eyelid. You will hear that frequently in 3D because it's a constant issue that always has to be dealt with in some way in many different kinds of projects. Because we don't have, with this technology, the ability to just have objects behave as if they had real solidity, like in the real world. We have to create an impression of solidity by manually setting where things intersect with other things. And when things intersect more than they should, we get clipping. I've made half my career out of fixing clipping between clothes and the bodies of figures. That's a major part of my core business at DAZ, actually. Does that make sense? Okay, now vertex groups. The reason you have to make the vertex groups first is because we're going to be using the Figure Setup tab in DAZ Studio to generate bones for the creature. And it will create a bone for each vertex group. If you don't create vertex groups, you have no bones, or you have to create the bones manually in DAZ Studio, and no sane person wants to do that. This method is much, much faster. Does that make sense? One vertex group equals one bone. Okay. Anybody else? All right, are we ready to move forward with export? I will mention the reason the gecko is gigantic is when you're modeling a creature that in nature is quite small, gecko or a spider or a frog, usually you are going to model it at a larger size, both for your own ease of working on it, but also so that the user can find it when they load it into the program. Because people are going to load this into a scene that's already mostly complete, and if there's vegetation and so on, they may not be able to find a life-size gecko. It's actually easier to have a bigger than life gecko and let the user scale it down. So you'll find this practice in a lot of cases when we're working with a very small creature. I know that with some of the mammals, I think Alessandro actually keeps those true to scale. So that's a different case, but the gecko is actually smaller even than something like a squirrel or a rat. So I'm going to leave it at a large size so it can be more easily found. You can see that I've imported Genesis 8 female here for scale. Not just so that I can have a giant gecko, but so that when I export, the gecko will be a size that it's actually visible in DAZ Studio, and it's not either a pinprick or too huge to be seen. So I'm going to just make sure that when I export, I use the same scaling as when I imported. It doesn't matter what scaling you actually use, as long as you're consistent on import versus export. So I'm going to go up here to File in Blender, and Export, and Wavefront OBJ. And then I will click on, let's see, I'll call it SY Gecko. You can't just call it spider or lizard or gecko or etc. because the metadata system in DAZ Studio requires a unique name for each item. There will probably never be another SY Gecko. If there is, I will call it SY Leopard Gecko or SY Crested Gecko or another name that makes it unique from any gecko that someone else might have already made. And then I will use my operator preset here, In brief, I've checked selection only, apply modifiers, include edges, and then down here to write normals, include UVs, write materials, and very importantly, polygroups and keep vertex order. Those need to be checked. That's very important. Otherwise, I don't alter the scale on export from Blender. So then I'll just hit export. And I'm ready to work on this in DAZ Studio. Today we're going to be working with the Figure Setup tab. If you don't have a Figure Setup tab, you can create one by right-clicking next to the tab list, and this thing will pop up that says Add Pane Tab, and you can find the Figure Setup tab on this list and click on it, and it will create the tab for you. We will also be needing the Property Hierarchy tab. So if you're going along with me on a project, you want to create one of those also. Once you have both a Figure Setup and a Property Hierarchy tab, I'm going to right-click in the Geometry List area, which is on the left of the Figure Setup tab here, and I'm going to choose Add Geometry. And then I will navigate to where I exported my gecko. And there it is, SY Gecko. And I will hit Open. And I used DAZ Studio's scaling on export, and I'm using it on import again as well. Which scaling you use doesn't matter. There are many. The important thing is that they are the same on import and then on export. Okay. Now, when I double-click the geometry that it's imported, you can see all of my vertex groups here. If you see something that's called null, that means that you have faces that are unassigned to any group, and you need to go back and find them and assign them to a group. Because if you have unassigned faces, it will not create a bone for those if memory serves. So I've got that, and I'm going to left-click on this and hold it down, and then drag it over here to the right side panel, and it creates this hierarchy. Then I'm going to click on this little button here to hide the geometry because we don't need that at the moment. Now there are some different things here that are important. At the very top, you can see that it's taken the name that I gave it and added a number. This was used to create unique naming in the poser era more. Now DAZ prefers that we not do that. So I will hold down left click on the name and delete that number. And I will do the same on the label. Every item has both a name and a label. On a figure, these will usually be the same. Down here I have the bones list. Again, it's created a bone for every vertex group. Now I'm going to talk to you about another important thing here called bone order. The bone order is basically what direction and what orientation the bone will have when it is created. By default, it's XYZ, which is, looking from the front camera view, XYZ is sort of from side to side. The only things that I actually need that for on the gecko are the eyes, because I want their eye bones to be facing out to the sides, and the upper legs. Maybe the lower, no, actually probably just the upper legs, because they're sort of in that horizontal plane. For most of the rest of the gecko, I'm actually going to be using ZYX, which is oriented sort of forward and back in the view plane from the front camera. So the gecko's body is oriented forward mostly here toward the camera. When you've got things that are oriented forward, those are usually going to need to be ZYX. So by holding down Shift and continuing to click, I can multi-select a number of bones. I can also hold Control to select discontinuously. Let's see. I just want the upper legs to be that, not the lower ones. And make sure I've got all the tail sections, all the tongue sections. There we go. And when I've got those selected, over here on the right, in the order column, I can right-click, and now you have the list of your bone orders. The three most important ones today Our XYZ, which as I mentioned will be the eyes and some of the legs, and then ZYX, which will be most of the forward plane of the body, and then the other one will be YZX. Now in Genesis 8 female, most of the body is YZX because it's used for vertically oriented bones. The spinal column, the head, and the legs are all in bone order YZX. Diagonal oriented parts around 45 degrees between the axis, Paul says. What do we do about those? That is a good question. It depends on which axis they are between. For something like the arms of Genesis 8 female, you could actually use YZX or XYZ. I would probably use YZX because the arms have further to go up than they do down. So down is a more logical resting direction for them. They're not perfectly in between the axes there. And very few things are actually perfectly in between the axis. If it's absolutely 45, like if it's absolutely a 90-degree bend and the bone is really right between the bend areas, then it may not matter as much because you're going to have to change the alignment, which I will be showing you how to do today. Yes, it is to do with the start and end position of the bones. If you get confused about this later on when you're working on this, you can also look at something like the Genesis 8 figures in the bone editor and see what their bone orders are, to give you an idea how some of that has been done by the professionals who make those figures. So over here on the right, I will right click and I'll choose ZYX, and then I will choose the eyes here. Those are already, I don't have to do anything to that, that's already XYZ. The ones that I want to be YZX are the ones that are oriented vertically. So basically just the feet and lower legs in this case. Does that make sense, that discussion on bone orientation? Do we have any more questions at the moment?
Yeah, has anyone in the room had to deal with that type of decision before, and whether they've struggled with that? Oh.
It didn't take me 12 years, Nancy, but it took me a lot. It did take me more than 1 year. I will admit that.
It's good that you're still learning.
Yes, you'll never truly be old as long as you learn. You keep the brain young and you're young. So, are we ready to move forward with generating our figure? Actually, no, we still need to do the order of these things because these are not organized yet with regard to one another. So I'm actually going to click and drag things like tail 8 onto tail 7 onto tail 6 to establish what is a parent or a child of what here. So now tail 8 is a child of tail 7 is a child of tail 6, and right on up to the hip. Tail 01 is a child of the hip. And then the body segments going from body 1 down to body 4, those are also children of the hip. And you may notice here on the gecko in Blender that the back upper legs are also children of that hip node because of where they are located. So those are on body 01 actually. So the back upper legs need to go on body 01. And then their lower leg and foot sections. Let's see. Tongue goes on the tongue. These things are all a bit mixed up. Tongue goes on the jaw goes on the head. And let's see, the head goes directly onto body 04 because there's no neck in this case. And then the eyes go on to the head. Okay, there's that. And then it's just a matter of getting the legs organized. And I will not make all of you watch me go through that process. I will just say that when you are ready to create your item, your creature, when you've got the hierarchy all set up here, then I'm going to go down here and click Apply Sub D so that it will generate subdivision when it creates it. And I will click Create. And it has created my gecko in the viewport there. Any more questions on the figure setup process here before we move forward?
Out of interest, if you struggled sometimes with the hierarchy, if you had to kind of make notes about it as you created the model in order to help you at this point later on, or did you just find it natural?
I find it to be relatively straightforward because it's actually much more that way than it once was. For example, it generated those bones relatively close to each other, like the body segments were mostly together, the tail segments were mostly together. There was a time in DAZ Studio when those would be in a completely random order, so you would have to scroll up and down a lot of the bone list to find body 04 and drag it all the way back up to body 03. Now imagine doing that with a creature that has 2,000 bones and 20 legs. That was the Mother Beast from the Singers of Kazor set. It took me 8 hours to do the hierarchy.
Now, I guess naming these objects in a strategic sense would really help, wouldn't it? So that if you're going to have your tail and body, ending up in the hierarchy, connected to each other, then you might decide to name it so they end up in the list. Because does it come in alphabetically?
No, it doesn't come in alphabetically, because if you look at the incomplete list over here,
yeah.
you put the back legs down here. I don't actually know by what principle it attempts to organize them when there are no numbers. When there are numbers, it attempts to organize the numbers in a 1, 2, 3, 4, etc. order. Now, it didn't always do that, but it does now. When there are ones that don't have numbers, it still seems to organize them somewhat randomly. Max is saying, can you fix the ZYX order after creating or importing? Yes, you can. I will show you how. That's a very important question, because you're going to screw this up at some point. I have done it many times. So you do that in the bone editor. So I've got my gecko here. It has no weight maps yet. It just has bones. But you can click on this sort of bone crossed with a pencil up here, the joint editor tool, or you can type Alt-Shift-J. And now I can see the bones that it's created for my gecko. And they're pretty good. But it looks like some of these actually may have the wrong bone order. The one on the back leg here looks correct. So let's look at the Tool Settings panel. If you don't have a Tool Settings tab, the procedure for creating it is the same as the others. You right-click in the tab area and choose it from the Add Pane tab list. And then it will show you where it says back leg upper, it says rotation order. And it looks like XYZ is actually the right rotation order for the upper leg there. So I'm going to click on the back right leg, and it says ZYX. So if I click on that drop down in the Tool Settings tab, now I can change that to XYZ. And you'll notice that it popped over into a different alignment. And I'm going to have to move that around slightly in the viewport. I can do that by clicking and dragging on these green and red widgets to ensure that that bone is in the right place. And I'm going to do that with these forward ones too, actually. Fortunately, a lot of this is a non-destructive process. A lot of the things that you do in the figure setup can later be edited in the viewport if things need to be changed from the way that they were generated. So DAZ Studio is good that way. Okay.
Oh, so, just to check, because I was helping Ted just then. Have you dealt with Nancy's question?
Let's see. Nancy's question was,
can you change the name of a body group after you've rigged a figure?
Yes, you can. Yes, you can. Actually, I will show you how to do that too. So I've also got bones that are pointed the wrong way. You really want when this is generated, you want the bone pointed toward, you want it pointed away from the source of the joint. So the shoulder is the source of this arm joint, and I want the bone pointed away from the shoulder. You'll notice that on the back leg here, it's pointed upward toward the kneecap, and I want it pointed down away from the kneecap. So I'm going to move the widgets and fix that. And I can also, if I feel they need to be realigned, I can actually automatically align some of the bones by choosing Edit and let's see. Nope, I want to go to Align, not Edit, and Align All Bones. And that will adjust the way these are aligned a bit. So the renaming a group. That is something that we do in the Geometry Editor tool, which you can click on this button that looks like a grid with a pencil over it, or you can click Alt-Shift-G. And here you have the face group list. If I want to change the head name, for example, to, I don't know, upper skull, I can double click on that and rename it upper skull. Now, I may need to reassign it to the bone because it may lose it because it now has a different name. So if that happens, I can go to the bone editor, and from the node list over on the left, I can click on the drop down and keep expanding until I find the head, because now the head bone is still called head. And it looks like it actually kept the assignment of that group to that bone. So it's still assigned upper skull to the head bone. So that's how that works, Nancy. Does that make sense? You just rename it in the geometry editor. You're welcome. So once the bones are approximately where they need to be, it's always possible to continue adjusting them. I just want to make sure that the figure is memorized before it gets saved. So when I'm pretty sure I have the bones where I want them, I will right-click and choose Memorize and memorize figure rigging. This is important because if you don't memorize the figure rigging before you save, you can actually ruin your entire figure and have to generate it from the hierarchy again. And if you've closed DAZ Studio and reopened it, it will not be retained in the Figure Setup tab, and you will have to redo the entire import and the entire hierarchy setup. So you really want to memorize before you save. Usually I memorize before I do anything more than the most basic rig and save, just to make sure I don't lose my bones. So if I'm going to do that, I will go up here and choose File and Save As and Figure Prop Assets. And I'll go to my directory I've created here. You can create directories yourself by going up to DAZ Studio Formats and then right-clicking and choosing Add a Base Directory. And then you can, I've got this folder called DAZ4 Test where all my works in progress go. And I've already created one called Gecko Webinar. You just click on the directory that you want to add, the folder, or you can create a new folder, and then click Select Folder. And then it will be added to this list. It's right there. It says Gecko Webinar. And I created these subfolders. If you don't have subfolders, you can right-click on your directory name and choose Create a Subfolder, and just keep on doing that in a nested list until you have the one that you want. So here I'm going to choose File, Save As, and Figure Prop Assets, and I will save in my Gecko directory here. And I'm going to call this SY Gecko Bones Only. I might just call it SY Gecko and keep overwriting it if I were working on a commercial project. But for purposes of this, I want to preserve the separate stages. I'm going to say Bones Only. And this Figure Prop Asset Save Options dialog comes up. Up at the top, you'll see it actually has the asset directory that is correct selected. But if it doesn't, you can click on this button and choose the directory that you're working in. Now, the use of having a new directory for your project is that when the project is done, you can just navigate to that directory and select everything in it and just use 7-zip or your other whatever zip program you use, add to archive. Now you have a testable archive file that you can share with others or that you can send to a tester at Daz3D or Renderosity or any other broker. So that's why I do that. So here it has generated my vendor name based on my preferences chosen in Daz Studio. That's Sickle Yield 2018 there. For product name, I'm going to say SY Gecko. And then for item name, it has already generated that based on the name that I told it I was going to give the character. So then I'll just click accept. Actually, I do want to compress the file. Click on that. It makes the file smaller. You can't text edit the compressed file, but it is possible to uncompress it to text edit it later. So then I'll click accept. And now if anything happens, such as Daz Studio crashes when I'm working with weight maps, which does happen, not invariably, but it's not uncommon, then I at least have saved my bones. Does that make sense? All right, I will go ahead and actually first I will talk about geometry substitution, because again, I rigged the gecko with the mouth open here, but if you want it with the mouth closed, okay, I have the, first I do need to rig it before I can do that, but I can go up here to, first I'll go to Blender again, sorry, and close the mouth with that shape key that I created, and then I will export this. Again, non-destructively, I'll call this one SY Gecko mouth closed, OBJ. And I can now substitute that geometry for the other one. You can't change the vertex order and do that. If I had added or removed vertices and faces from the gecko, you cannot substitute the geometry then. But if all you've done is change the shape, then you can. And this is very useful if you're making clothes and you need to adjust fit in the process, or you need to adjust some part of the shape without changing the number of vertices and faces. There's sub D turned on here so you can see it looks a little smoother. I will go to Edit and Figure, and then Geometry. And then I'm going to go down to Update Base Geometry. And I can say Update Vertex Positions or Update Full Geometry. The Full Geometry option is something that you can use to update the UV if you have changed the UV. So then I'm going to click OK. And again, I can navigate to my mouth closed gecko that I created. There it is. And there we go. It just updated it to have a closed mouth. Now you will notice that now the bones are in the wrong place. So I will need to adjust the bones of the mouth and tongue. And you don't want to do that by bending them, because then you've just bent them. You haven't permanently changed their alignment. Changing their alignment you need to do in the Tool Settings tab. Here you can find the center point, end point, and the orientation. The center point is the green widget here. The end point is the red widget. And the rotation, the orientation, is how this bone is rotated compared to the original ZYX or other orientation that it started with. So you'll notice that if I click on this red widget and drag it, it changes numbers in the endpoint option there. And they turn white, indicating that it's not memorized now. It's departed from the memorized arrangement. So to change that, I'm going to go down to orientation and change the X rotation on all of those tongue bones, like so. I'll be showing you another option if you want to leave the mouth open and just have it closed in Daz Studio. That'll be covered as well, because that's what I ended up doing with the snake. There we are. And then I will memorize figure rigging again when I'm finished with that. And now I'm ready to begin creating weight maps. Now, DAZ Studio will actually generate basic weight maps for you. So in order to do that, I'm going to hit Alt-Shift-W to go to the weight map editor, or you can click on this barbel or weight with a paintbrush across it up on the top bar. You'll see that there's nothing on the left here in the Tool Settings tab because there are no maps yet. But if I right-click in the 3D window, I can choose Weight Editing and Fill by Bone Selection Groups. And then it creates a new weight map, a new group, for each one of those bones. By default, those are very sharp-edged, and they are each at 100%. And more importantly, by default, they also are all triax. And for most DAZ Studio things now, we prefer to use a different type of weight mapping that is not triax. We prefer to, it can be called general in DAZ Studio, but it's also called dual quaternion. So to change to that, I will right-click and choose weight editing again and weight conversion, and then convert triax weight to general weight. And then I need to also clear the triax rigging, so I'll go to weight editing, clear weight, and clear triax weight. There we go. So now, if I click on one of the body bones, for example, I now have a general weights and a scale weights map. And you will see that the general weights map is, it's mostly red. There's not a lot of blend between the different groups. And the result of that is that when I bend a bone, it looks kind of weird. Geckos don't really bend at a 90-degree angle in the body. In fact, pretty much no creature does. So we want to smooth in between these groups. We can smooth all of the groups by default if we like, and then tweak them individually. So in order to do that, I'm going to go back to the geometry editor by clicking on that button and choose geometry selection and select all. And then I can go back to the weight map editor. And I need to select all of the bones so that I can smooth all of them at once. So I'm going to click on the hip in the Scene tab, right-click on that, and choose Select, and then select Children. Now, all of the geometry is selected, and all of the bones are selected. And I can right-click in the viewport again and choose Weight Editing and Smooth Selected. Now, on the Smooth Selected dialog, the number of iterations here, I don't 100% understand what that does. I think that it makes it more smooth, more smooth in the transition area when you have more iterations. But the smooth factor affects just how much it is decreased in strength. Like, if you have a low smooth factor, it won't be smoothed a lot between groups. If you have a high smooth factor, you can actually have it smoothed so much between groups that you can't get a sharp bend. So I'm going to use around 25-27% to start with, and then I'm going to click Accept. You can see that there's just the hip bone visible there, that hip map, because that's the first one that I selected. So it will only show that one, but it will be smoothing all of them when I hit Accept. And it's going to take a minute to smooth these based on how many there are. There we go. If you have more than 100 bones, it can take more than a minute. Again, on the Mother Beast, which had like 2,500 bones, it took more than 10 minutes for DAZ Studio to run the smoothing process. So just be aware that if it seems like it's frozen, it might just be working on the smoothing. Give it a few minutes. Okay, so now if I select those body groups with Shift-click in the Scene tab, and I move them side to side, we have a much smoother bend, just like that. So that's our basic, they have a basic rig there. If we have an individual one that we want to be different from that, well, there's a good thing for us to fix. The arm's not bending right. Why is that? Let's look at those bones again. It's because this one I missed somehow and it's aligned incorrectly. So I'm going to have to change that back to XYZ here. That already looks better, see? And then I move this point around, and you can actually watch it, the weight map, moving with the bone position until it looks more correct. And then when I use that bend again, that's not so bad. But you'll also notice that the bend looks kind of chunky around this lower body area here. I might want to see if I can do anything about that with the weight map. So to do that, I'm going to hit Alt-Shift-W again, and now we're going to look at manual adjustment of weight maps. You want to do as little of this as possible because it is time consuming, but sometimes it will be mandatory that you do it, especially at the edges of joints. So up here you have these buttons. The important buttons for today are the paintbrush mode button, which is by default selected, it has a P on it, and the smoothing mode brush, which is this other one here. I'm going to start with the smoothing mode brush. And I'm just going to, actually I'm going to deselect the geometry first. I don't need that selected. There we go. Then I will just left click and drag around the bend area here to try and smooth out that bend. And I'm improving it a little bit, but not a lot. So that looks like something where I'm probably going to have to do a joint controlled morph to give it a better bend. Now, before we get into discussion of how to do that joint controlled morph, are there any questions about this part, about manually editing your weight map? Or about creating your weight maps in general?
I was just going to ask you about that figure of 27. Is that just something that you've come up with over time for the smoothing? It was the smoothing factor, wasn't it? Was that something you've just sort of come up with as a good starting point?
Yes. For things with joints like this, with things with joints that have sort of these harder bony bend connections, like the gecko, you want to use less smoothing. I use more smoothing on something like the snake, where you're actually having to use fewer bones to imitate the look of many, many tiny bones. Then you have to smooth between them more to create a smoother curve. So that is something that I've learned by experience. I've never found anyone documenting that number or what to do with that. Ted says, can you select faces and remove bone influence on those selected faces? Yes, you can. Yes, you can. I will show you how to do that. Good question, Ted. So I actually have to do that on clothing relatively often. You don't need it as much on a creature, but it certainly can happen. So if I want to remove the influence of this bone from this arm, for example, I will go to the geometry editor again, and I'm going to right click and choose selection mode. Here I'm going to choose marquee selection because that lets me just drag a square here, and then it will select everything inside that square all the way through in a cross section. So then in the weight map editor, I will go here to weight editing again and choose fill selected. And I can fill this with anything from 0 to 100%. I'm going to fill it with 0%. And now that geometry is not affected by the bone at all. So you can see it's dragged back to its original position there as the geometry around it remains bent with the bone. Hit Control Z. And we use this a lot with, we also use this a lot with creating D-force items because you need to use filled with 0% on D-force to prevent things from being simmed that don't need to be. And I'm sure Arki will be going over that for those of you that are signed up for her D-force webinar, which if you're interested in D-force sims and clothing, you absolutely should. So that's how that works. Any other weight-related questions? It's a complex area that is a problem for, this is one of the big hurdles for a lot of people in creating either clothing or a creature, is having to manually tweak areas of the weight map. So now is a good time to ask those questions. Max says, for testing, how do you put the arm back to its default state? Well, I will click on the arm and I went back to translate mode here by clicking on the translate tool, the widget, and then I will hit Control E, and it resets the bone back to its saved position. When you memorize it, it memorizes the position of that bone as the default state. And in fact, I probably need to memorize this again. Yep, I've got white letters here in the tool tab, so I'm going to hit memorize figure rigging again there. In fact, I can pose this in all kinds of ways. I can use the IK and just click on bits and drag them around all over the place in any horrible configuration. And then if I click on the root of the gecko itself and Control E, it just resets the transform position. But to reset the whole figure, I can hit Control Shift F. And it resets everything back to its default position. That's a good question. You will need to do that a lot in testing. Good one, Max. Anyone else?
I was just thinking, when you first was tackling this kind of operation, were you kind of agonizing and constantly looking at reference images to say, oh, this particular bone should be just so with this type of creature or with this type of character? Did that slow you down, or are you now at a point where you just kind of eyeball it and say, well, yeah, that'll do? Because I imagine particularly a newcomer will agonize over getting everything just perfect. Do you know what I mean?
Yes, I do, and that is very true, actually. I usually spend more time on that at the mesh level when I'm creating the original geometry. But let me find my gecko source pics. I actually worked on this from some different online references, and that is actually covered. There's a discussion of references and how to find them and how to use them in the bonus video. That's not a gecko, that's an anole, but there's, I chose the leopard gecko because it's cute. It has such a big head compared to its body size. And I do spend a lot of time with any creature agonizing over the proportions of the joints and the bends of the joints and the limits, which we're going to talk about next. Because creating limits is an important part of the artistic process too. But absolutely, yes. When you're talking about a creature that needs to be able to be posed and animated, you're going to spend a lot of time looking at movement references for that creature. That's never completely escapable if you want to be accurate. And I will be the first to admit there are people in our market that are much better at going from reference to a living looking creature than I am. But even I spend a fair amount of time saying, is that really how the leg would bend? Or, and so on and so forth. That's a good question. That's where the artist meets the technician at that point.
Okay, thanks.
Okay, so limits. Let me see if I've got a separate. Let's see. Let's look at my stage 2 base rig here. Did I set limits on this? Maybe I didn't. Okay, so for setting limits, this is important because while you as the maker of the thing might be willing to just say, well, I'm not going to bend the jaw 180 degrees, that's stupid. You can't offer it to a broker that way. You need to set a reasonable limit on how the jaw would actually open on a living creature. In this case, I'm probably not going to allow it to open past about 49 degrees. That's actually pretty close to what the gecko can do in real life. They can open their mouths pretty wide. So I will open it to the amount that I think is useful here. And then I will go in the parameters tab to the bend parameter. And I'll click on this little gear up on the top right, and then parameters. And you can see that that's called X rotate. If I had generated these without creating them in the figure setup tab, all of the bones would say X rotate, Y rotate, Z rotate. One of the reasons for using figure setup is that it generates the names bend, side to side, twist for you. So here, by default, the minimum is -180 and the maximum is 180. I'm going to set the minimum to 0 so the jaw can't be closed in on itself. And I'm going to set the maximum to 50. And then I will click accept. And there we go. Now it will only bend as far as I've told it can open, just like that. And I will do the same with the legs, the arms, etc. The gecko is actually not a very flexible creature as regards raising the leg, so I'm probably not going to let it go further than about that, and even that is probably not entirely realistic. But I'm going to go, so that's going to go from 0 to 63. Then I'll need to go to the other side, and it'll probably need to be negative 63 to 0. You can see the bone is messed up on that side because we haven't adjusted all the bones on that side. That's how limits are set up, and we'll need to do that for basically every joint on this creature. There are some where I think at one point I multi-selected. You can actually multiply select, say, all the body segments, and then go up here to the parameters tab and hit this button and choose consolidate properties. I just leave that on by default normally. And make sure that display separate items is not checked. So now when I have the 4 body segments selected, I can bend or side to side, etc. all of those body segments at once. And because the gecko's body bends in a pretty smooth curve through that area, I'm going to probably give all of them the same side to side limit of, say, negative 30 to 30. Now, the twist here is going to be, there's not going to be much of a twist there because, again, that's not very natural. So I'll probably set that to like negative 20 to 20, something like that. And then for the bend, maybe negative 25 to 25. There will be things like the jaw, I'll go back to the jaw here again, where you don't want it to go side to side by a lot. You might allow a little bit because the real gecko can actually move its jaw side to side just a little bit, but not much. That's actually going to be like negative 8 to 8. I don't really want the twist to be usable at all. In that case, what I'm going to do is I'm going to right-click on that parameter and choose Edit Mode, and then right-click again on Twist and choose Hidden, and Hide Selected Properties. You can still see that because I have Show Hidden checked up here, which you pretty much always want left on when you're working with something. Ah, Ted says, can you mirror or symmetry rigging, weights, or constraints? Yes, you can. Let me try that here. Go to the weight map editor, and I will click on one of the front legs. And I will put both of those to roughly the same position here. And then on the weight map editor, while you're working, you can actually go up here and tell it to use symmetry. It will not then create symmetry if there isn't already symmetry, but it will then edit symmetrically from that point on. So if I were to hold down Alt and erase some of the bone adjustments on, some of the bone editing on this leg, it will then mirror that over to the other leg. It doesn't want to do that on this because I didn't use the naming convention that it likes. So let me load up a Genesis 8 female here to demonstrate what that's a way to do that. On Genesis 8 female, you will notice that all of the bones start with a lowercase letter that is an R or an L, and then the name, and then a number. So DAZ Studio likes you to start with little r, little l on bone names. I didn't like to do that because I wanted the bone name to be the same as the bone's label. But if you make everything no spaces, start with a lowercase l, lowercase r, then in DAZ Studio, you can select her. And I'll mess a little bit with Genesis 8 female and demonstrate this. I can tell it to use symmetry, and then when I do that, hold Alt and erase trick again, and I deliberately bork the arm bone here. Hang on. It will edit the other side at the same time in roughly the same way. How well it does that depends on how symmetrical the mesh is. If your mesh is not perfectly symmetrical, there's not much point in attempting to use symmetry here. There we go. See, I've created a divot in the shoulder and it created a divot on the other side. Genesis 8 female has a perfectly symmetrical base mesh. The gecko does too because I created it with a mirror modifier. If you have an asymmetrical mesh, you cannot use symmetrical rigging. The other thing here is if I forgot to use symmetry in the weight maps, but I want to mirror symmetry back over to that other side, you can also choose weight editing and, let's see, weight map symmetry. And then set it to entire figure or selected bone. And then across the x-axis here. And then I would choose right to left because the right one is the one that I edited. And there we go. It just edited it right back to match that one. That's a really good question. That can save a lot of time if you have a symmetrical creature or object and you have correctly set up the names. I'm glad that you brought that up because I didn't set up the names correctly on the gecko for using that process. But you can save yourself a fair amount of time, especially with a complex creature like a biped. Okay. So we set up our bones, we set up our basic weight maps, and we've talked about some weight map editing and some editing of the bones and geometry replacement. Now, I mentioned that I was going to describe another way to deal with the jaw, which was that I closed it manually like this, and then I will go and set the bend here to where the bend value is the one that I want it to go to as a minimum there, negative 11.93, and I will set that to the default value in the parameter setting. So when you click on that little gear next to the bend parameter of the jaw and click parameter settings, and then you have an option here below minimum and maximum to say default. So if by default I say 11.93, now when I save the gecko again and load it from the library, it will load with the jaw closed like that. So even though I modeled it and rigged it with the jaw open, I can save it with the jaw closed, and it will be closed by default for the user. If you choose, you can choose to do that instead of the geometry replacement method. Those are both things that you can do. Now for JCMs, you probably noticed when I was demonstrating the bend of this arm that there's only so much that you can do with the weight map. You still get some weird chunking, for lack of a better term, around this shoulder area. And I can fix that with a joint control morph, which I'm going to demonstrate right now. So in order to do that, I need to set this back to base resolution. So I'm going to go to the parameters tab and the mesh resolution option here and click on base and then sub V level 0. And I will then export this to wavefront again under my gecko creature. And I will call it PJCM because currently that's the official name we're supposed to use for joint controls. I will call it PJCM front left upper bend. It needs to have a descriptive name that distinguishes it from any morphs that I might have that fix the bends of other joints. So it needs to describe both the side and the position. So I'll hit accept there. Then in Blender, I will import that. Front left upper bend. There it is. And in Blender, there's my gecko with the leg bent. Now I'm going to use Blender sculpting tools to smooth out that bend a little bit. Try to make it look more organic. And if you can find a picture of a gecko with just one leg bent in exactly that position to use as a resource, that is great. With a creature like this, where its movement has been less studied, you're probably going to have to eyeball it a little bit. And there's less consequence for needing to eyeball it here because, whoops, I need to turn off symmetry there because it's trying to edit the other side. There we go. There's less consequence for eyeballing it a little bit on the gecko because with a human or a cat or a dog, people look at those so much that they have more of an instinctive idea what they should look like. So there's actually an uncanny valley for when a limb bends wrong on a person, or sometimes even on a dog or cat. People don't really watch geckos that closely, so if you get a bend a little bit wrong to where only another gecko would notice, you're probably okay. But you're going to need to really exhaustively examine your references if you're looking at a human being or any creature that resembles a human being or another creature that people look at just all of the time. Once I've got that smoothed to my satisfaction, I will choose File and Export, and Wavefront again. And I'm just going to overwrite that one that I created. Then I'll go back to DAZ Studio, and I will click on that limb that is bent. And I'm going to, I don't need to have that limb clicked for this part, but I will momentarily. I'm going to click on Morph Loader Pro. It looks like a bicep with a letter P on it, sort of a flexing arm there. And I have some options here. I need to leave the From preset up here on DAZ Studio because that's what I use for import and export. Again, it doesn't matter which preset you use, just that you're consistent across your project. Then I'll click Choose More Files, and I'll go to that smooth exported gecko that I just exported from Blender. Now, to make this work, I need to right-click on Reverse Deformations here on this line and choose Yes. And I also need to right-click on the property group. And I'm going to, there's actually already a hidden JCM one here, but if there wasn't, I would click Create and then type hidden/JCM to create a hidden node where the joint control morphs go. We don't put those in the actor section. They have their own separate section. That's kind of doctrine, again, with DAZ 3D's figures. So then I will click Accept. Here we go. And now if I go to that hidden group, I can find my left upper bend. And when I dial that on and off, you can see it fixing that bend. So now how do I make this work just when the joint is bent and not always on or always off? First, I'm going to set it to hidden in the parameter settings here. And I'll set the minimum to 0. That's important. Then I'm going to right-click into edit mode there, if it's not already in edit mode. In this particular case, I should be able to just click on the joint and find the bend. And again, click that into edit mode if it isn't already. And now I will right-click on the bend and choose ERC Freeze. And it should automatically generate a correct code. I will show you how to edit it in case it doesn't. I'll click Accept. And now, looks like when I bend that, it should be correcting with my morph. And to check that, I can go to the gecko here and the currently used heading, and it will show me which joints are currently on. There's a mouth closer JCM that I did earlier as an earlier part of the setup for the project, and there is my automatic bend that I made. And then when I hit Control E to zero out the joint, I can check, and that JCM is not on anymore. So then I will save my morph using Save As, Support Asset, and Morph Assets. And I'll just say Base under my vendor name there. And then I will say, click on the JCM that I just made, and then I'll click Accept to save it. This process can be exhausting because you're going to have to do a lot of JCMs across a creature that has real joints. Again, like a gecko or a dog or cat or a person. It was easy with the snake because I didn't really need to do any JCMs for the snake. And again, for a tentacle creature, you don't necessarily have to do any. But when you're looking at a real animal, you're going to have to fix a lot of the bends. That's just how it works. Are there any questions about creating joint-controlled morphs?
Out of interest, you say you've created a snake. What other creatures have you created? Was the snake the very first that you chose because of knowing it was going to be a relatively simple creature to create?
No, actually. The only creatures I have in the store are the snake and the Singers of Kazor set, which has like 4 monsters in it. I did the monsters first. I was a little too ambitious, actually. That was an exhausting project, not because of the number of joint controls, but because of the sheer number of joints, and pose controls that I had to do. I did the snake because I noticed that the Daz Python was really old, and I like reptiles and amphibians and insects, so I'm probably not going to be the person to create the next Daz cat or dog, but I thought, hey, I can make a better snake than this.
Mm.
So I did a snake because I wanted to have that be my first real animal because it would be easier than my intended future spider and octopus that I want to do. So that was why I did the monsters first.
Yeah, not the snake. Yeah.
Yeah. Okay. So that's how you do JCMs. Some of you probably have seen some of that JCM workup from having come to my other webinars, which is great. And the other thing that I'm going to address right now is how to close the eyes. Those obviously are modeled open, and we need to be able to close them, but we can't just put bones in the eyelids. You can sort of do that with something like Genesis 8, but in the case of the gecko, I did not put vertex groups for every section of the edges of the eyelid, and I don't feel that that's necessary with a creature like this that has less subtle facial expressions than a human being. So in this case, I'm going to close the eyes with a morph. And in that case, that's why I have this shape key that I created that just closes the eye. So I will export that shape key as a wavefront again. I close R there, and same export settings. You have to pretty much do the eyes separately so that the user has the option of opening or closing just one eye. You could do them both at the same time, but that's giving your user only the ability to close both eyes at once, and that's usually not going to be good. That's not usually going to be what the customer wants. So in this case, I will go to the morph loader again. Actually, I'm going to have to open the mouth there because I originally modeled the eye closed with the mouth open. So I will go back to the morph loader here, click on the eye close morph, and again we're going to use reverse deformations. Actually, no, I might not need to use, let's try it without the reverse deformations here and see how that does. That's going to go under pose controls rather than, again, actor or hidden. Okay, and let's see how that does. No, I didn't actually need to reverse deformations on the eye. That works fine. Reverse deformation, Nancy, that's what we use to do the JCM, the joint controls. You use that when you need to change something about the figure, but only in one position. Because then when you do that, like I did that earlier with the leg bent, if you load a morph with the leg bent normally, the morph doesn't take account of the fact that that leg is bent when it loads the morph. When you reverse deformations, you're forcing it to look at the fact that the leg is bent and correct against the leg bend with the morph. That's what reversing deformations does, and that's why we use it to make joint correctors. Does that make sense? That's pretty key to, yeah, that's why I was using it. Good question. That's pretty key to fixing joint bends, so I'm glad you asked that. So now I have this eye bend here. It's like that. And I'll set the minimum on that to 0. And I might actually give this one a different name. Like I'll go down here to the label and change it to close right eye. Then I will go back to Blender and create another key. And I can change the name of the keys here, by the way, by double-clicking. So if I want this to say close IL like that, I can. And I will just use Blender's connected proportional edit to tug that eyelid into position. Again, in the bonus video, I talk about making sure there's enough geometry in this area to get the eye closed. There have to be enough that you can get the eye all the way closed without mandatory clipping in the eyelid area. It's very hard to have a figure made with like 200 polygons and still have eyes that close, for example. Okay. I need to turn off that right eye closer before I export this. And if you remember from my reference images that I showed earlier, the gecko has these big ol' eye ridges here. That fascinates me, like looking at it from a design standpoint. Why does the gecko have those giant ridges around its eyes? Do they protect it from the sun? Do they protect it from like moisture in a tropical climate? I don't know, but they're interesting to me. They almost look like an eyelash, but they're not. They're scaly. I'm just exporting the left one here. And I'm going to load it in the same way. And I've already created the pose control heading, so I can just right click on morph/morph loader here and choose pose controls. You always need to create a new group here. Don't leave it saying morph loader pro. That's like saying I don't know how to do my job, or I'm too lazy to do my job. When you always change that morph heading name. That's a huge pet peeve of mine, because I've seen commercial products that still had the morph/morph loader pro heading. That should never be the case. That's actually intended as just a placeholder for the real group name. Okay, and I'll do the same here. Set the minimum to 0 and change the name. Not the name, actually the label. The reason I made you go through watching me do the left eye is because I want to show you how to do a double eye closer using an ERC control. So to do that, I will drag both of those eyes all the way closed. And now the user has the option of closing one or both. And I will go over here to the property hierarchy and the tab that I told you to create earlier. Again, you can do that by right-clicking in the tab area and choosing Add Pane tab. In the property hierarchy, I will right-click and choose ERC Freeze. Under Node, I'll just choose my gecko. And then for property, I'm going to click Create New. And the Create New Property dialog pops up. Under property type here, we have some different options. The only two that I've used were float and bool, which stands for Boolean. If you choose Boolean, you now have only the option of having it be off or on, whereas with float, you have the option of having it have a minimum value and a maximum value. The off-on option can be useful if you have a creature with a feature that needs to not have an intermediate stage, like say you're morphing a crest on and off, but the crest doesn't really look right at the middle stages, only at the full value of the morph, then you might use a Boolean to ensure that the morph is an on-off state. Does that make sense? The Boolean is a special case that doesn't get used a lot, but I thought I'd cover it because it can be really useful in the right situation. But I'm going to leave it at float for right now. So I'm going to name it CTRL close eyes. We use the CTRL part of the name to indicate that it's a morph that controls, not a morph, but a dial that controls the use of other morphs. This might seem weird, but it's not actually. If you ever use Victoria from the people heading, and you dial in the entire Victoria character, that's actually a CTRL Victoria 8 dial, because it controls both the Victoria body and the Victoria head. Those are two separate morphs in Genesis 8. So this sort of ERC freeze dial has a lot of uses in controlling the use of multiple morphs. So here I'm going to just call the label close both eyes. And under path from the dropdown, I will choose pose controls again. For type, I'm going to set that to modifier pose, not modifier shape, because this is a sort of a pose that controls two morphs instead of being a morph itself. I can change these colors if I like. Some people do. You can change those to different things. If I make it blue and yellow, I'll just change it to blue and yellow so you can see what it ends up looking like. Usually I just leave those gray and white. I'll go down here and set the minimum to 0. And you can change the sensitivity as well if you want it to the dial to be less sensitive or more sensitive. I leave it as %. It doesn't matter if you have it as a percentage or a decimal, really. That's more up to you. Then I will click Create. And here it's picked up the X rotate bend of the jaw as part of that, so I'm going to uncheck that. But I'm going to leave it with the 2 eye close morphs there. Then I'm going to hit Accept. And now it has created this close both eyes dial. You can see that it now has a gradient from blue to sort of yellow at the other end because I gave it those presentation colors. And I drag that off and both of the eyes open. And I drag it on and both of the eyes close. So that's how you create a morph to close the eye and a control dial to control the closing of both of those eyes. Does that make sense? Do we have any questions on how we use those ERC dials, or maybe some other situations that you'd like to know about where you'd like to use those? I'm going to do one for the tail movement here in just a second.
Yeah, I'm trying to think of the creatures that were suggested just before the webinar. So one person was looking at a giant centipede, somebody else was looking at a squirrel. So yeah, what kind of JCN, what kind of examples could we pull for those type of creatures?
Christine says, would it be in setting these that you would check for the clipping you showed us in Blender? Yes. I didn't actually totally show you the left eye because it doesn't look good. I did it just quickly in like a minute there, so it actually isn't closed all the way. So that's not a clipping problem, but it's the same sort of problem. And I would probably fix that in Blender before I saved the morph and the dial. But with what Paul said, I would use pose controls on the centipede to create movement of the entire body because you're going to need a lot of bones. So to do that, like for example, I can create a pose of the gecko's entire body. I can select all the tail bones. If there were 50 bones in the tail, this would work the same way. I right click on tail 01 and select and children, whether it's 8 bones or 50. And now I can choose side to side for all of those. And just as you might wish to do with like the second half of your giant centipede, so that you can make S-curves with the body shape. And then I will go to the property hierarchy again and ERC freeze, and it's just that same procedure. I choose the gecko and create new, and I will call it CTRL tail side side. Then I'll call it tail side dash side for a label, and also put that under the pose controls. Genesis 8 has a lot of pose controls that are like this, basically. This one I'm going to leave -1 to 1 so that I can swing it from side to side. So then when that's created here in the pose controls, I can just use that to make the tail swish around like this. And you can do this with your squirrel tail, or the second half of your giant centipede, or your octopus arms, any long multi-boned thing. Your pose controls can be very useful for that. And I can also use that to make a control that bends the body from side to side, moving all of those bones or anything like that.
Yeah, I think it's considering each creature and thinking of some cool movements, poses for that creature that I guess you would have expectations for. So for the squirrel, it might be, there's a classic pose of the two, handling a nut or something very close to its mouth, kind of nibbling that nut. So you'd have some kind of pose control to bring the arms close to the mouth, I suppose, for a squirrel.
Or I have a question. I have an idea on that actually, because it's easier to model the squirrel's tail out flat, because it's always easier to model a straight thing than a curved thing.
Yeah.
So you could model the squirrel's tail flat, and then create a pose control like I'm going to do this with the gecko, and it's going to look
Oh,
silly
to
here,
curl
but
it up, yeah.
then you can create that stereotypical squirrel tail curve
Yeah.
with a pose control.
That's good, yeah.
That's what I would do if I was making a squirrel. Because then you also have less texture distortion, and it's easier to paint your textures, which is what we're going to cover tomorrow. The flatter the body is and the more open, the easier it is to texture it. So that's another reason to like model the squirrel's tail flat and use a pose control to put it into an upright tail position.
Yeah, I think that's definitely inspired Max.
Great, that's great. Max, I hope that you'll email me or something when you get your squirrel done. I'd love to see it. I always love to see projects that people make after these webinars. And I'll be giving all of you my email at the end of the webinar here, which is we're pretty close to wrapping up here. I think I will go over how to make a body morph with bone adjustment real quick. Just a very simple one. For example, in this case, I'm going to lengthen the gecko's tail. And I'll create another shape key for that in Blender with tail length. Leopard geckos have a really short fat tail, but suppose I want to use this as a different species of gecko. I might wish to lengthen its tail, a more arboreal species. The arboreal species do often have a somewhat longer tail. So I will grab that and drag it on the y-axis. Turn off the X mirror here. There we go, until my tail is somewhat longer. It doesn't look longer, it's like turned on the morph thing there, the shape key. There we go. So now the tail's long, and I will export that and call it tail length. And once again, back to Morph Loader Pro. Now this morph, I need to create the actor heading. This one goes under actor because it's not a movement morph or a movement pose, it changes the shape of the body. So that's going to go under actor, and I'm going to say body. Again, if you look at the way this is organized on Genesis 8, you'll see tons of groups under actor for all the different body areas. So I'll hit accept there, and it creates my morph. And I probably want to set a minimum for that, because if I go all the way to -100, it doesn't look right. I'll probably set the minimum to like -38. But the important thing here is, if you look at the bone editor here, when I have that morph on, you can see that the tail no longer fits the bones. The bones no longer fit the tail. So if I swing the tail from side to side, it looks really weird now because it's not lined up with the bones. So to fix that, I will first make sure that I have that morph dial on, and I do. And then I will go to Edit in the bone editor here and choose Adjust Rigging to Shape. And in this case, I'm going to uncheck all. I right-clicked and hit uncheck and all. And I'm going to just click on Tail 01 and right-click and choose Check Selected and Children. So I just have the bones of the tail there. And I'm not going to adjust orientation because in this case, I just want them to be longer. If I had changed the shape of the limbs, for example, like I made the arm longer, I would need to also adjust orientation. In this case, I'll just go ahead and let it do that and see what happens. Let's see. There we go. Now the bones have stretched out to match the length of the tail. They've adjusted to the new shape. So then I'm going to go to the tail length here in the parameters and right-click and choose ERC freeze. And you can see all of those Y origin, Z origin, etc. That's just describing the way that the bone positions have changed. So I'm going to click accept. And now when I dial that tail length up and down, the size of the bones dials with it. So that's another thing that gets done on all of Daz's morphs that change the character's height or the length of the arms or the position of the fingers. That's what that bone adjustment process is for. Okay, any questions on how to do a morph with bone adjustment? Any special cases you'd like to discuss?
Yeah, think about the creatures that you're wishing to make and cases for those.
Oh, I missed an earlier question, sorry. Max said, I guess I would use it to close all the fingers, or wait, that's a pose control. And yes, closing all the fingers is a pose control, and actually, again, Daz's Genesis 8 has a bunch of pose controls for doing that exact thing, for closing the fingers. Nancy says, I get a vertices don't match when I use Morphloader Pro. Yes, that happens if you have exported the gecko or whatever your creature is at high resolution and not base resolution. Then the number of vertices will be wrong, and I'm afraid at that point you have to go back and start over because the number of vertices has to match. It has to be the base. It has to be the base count. The other thing that can cause a problem is I've accidentally had this happen working on clothes before, where I created a primitive cube, not cube, a plane, and then I forgot the plane was there, and I exported the plane with the creature, and that caused the vertex order to mess up, and I had to start over. So you want to make sure that you have nothing else in the scene except your creature, and your creature has to be set to base resolution to do those morphs. Geographs. No, we're not covering geographs today, Ted, because that is an entire different area of its own. I actually have a free YouTube video you can watch that is just about geographs on my YouTube channel at www.youtube.com/sickleyield. But that is actually a long enough area to have its own tutorial. It does not exactly affect joint alignments, but that is covered in that video. So a little plug for my YouTube channel there. It's not a monetized channel, it's purely for informational purposes, but you will find a fair amount of information that is not able to be covered in the webinars directly. So that's a whole big area all its own. And I love geographs, I've used them a lot, but they are definitely a pretty advanced rigging thing, and they do take some additional workup. So I guess I could talk briefly about UV maps. I'll need to talk about them again next time, because next time we're going to talk about texturing, and those are directly related to one another. But I also talk about how to create a UV map in, again, the bonus material. But a couple of tips here on that. In Blender, you create a seam by, you can alt right click anywhere in the scene to select a full edge loop, like this. Got one that goes up to each side of the tail here. If you want those to be, you can see that I've set up seams along those. And then when you've selected that, you hit Control E and mark seam. And it takes, creating seams is a bit of an art form in and of itself, because you want to create enough seams that there's as little stretching as possible, but you want to create few enough seams that you have less work to do with texturing. Now with the gecko, there's pretty much no way to texture this in a 2D program. It has to be done in a 3D program because I emphasized no stretching over fewer pieces, so there's a bunch of pieces. This would be a nightmare to texture with a 2D program because you would have to try to adjust the texture at all of those scenes, all of those seams bit by bit. You don't want to ever do that if you can avoid it. But I made this planning to texture it in 3D, which is what I will be doing tomorrow. I know I've said next week when I meant tomorrow, at tomorrow's webinar.
Yeah, it's tomorrow.
And yes, tomorrow. And then the other thing there is that you can see those all fit on one, but I've made the eyeballs a separate UV map. It looks like they overlap there, but in fact, the JPEG that has the eyeballs on it is a different texture file. So that I wanted to do that so that I would be able to put more detail on the eyes, and that's pretty typical. Most figures have the eyes on a separate piece. There are a few authors that choose not to do that. Now, Ted is asking, can you talk about figures that have separate mouth or teeth meshes inside the main mesh, and any issues there? Now, in the case of the gecko, the mouth here is a separate material zone. It's not a separate mesh. That's typically like building that in is the tricky part. If you want to give something teeth, rigging those is not usually difficult because you're usually just going to assign them to the vertex group of the upper or lower jaw. When you're meshing them, you're going to have to subdivide more again to be able to create sockets in this jaw area here, because you need to be able to take one of these vertices in the jaw and drag it downward to form a socket, so that if I put a very crude little cubical, see, tooth here, where's my cube? Fit it into a little socket in the jaw or in the mouth. And if you want to have the mouth be massively subdivided compared to the body, having it be a totally separate mesh is something you might try, but it's going to be hard to make that match up perfectly at the edges, which is why I don't like to do that, and Daz has not really done that much with their figures either. But that's what you would do, is you would create a little divot here, and then you would probably subdivide a cube and then drag it roughly into a tooth shape. This is a bit stupid on this particular thing because geckos don't have teeth, but you basically would just do that over and over again, like that. Max says, are rigid bodies controlled with the weight map setting? What do you mean by rigid bodies? In this case, like teeth. Yes, they are. In that case, I would have just, let me undelete that. I would have joined that to the main body here, and I would select the tooth, and I would just add it to the vertex group of the jaw. See there? And I would assign it, so then when the jaw is moved, the tooth will move. So the teeth are actually not even separate from the rigging of the rest of it, unless you do a JCM to push them down when the mouth is closed or something. Teeth are actually very easy as far as the rigging is concerned. They're only annoying and difficult when you're working on the base mesh, really. Does that make sense, Max? Okay, good. He says yes. So yeah, that's all you really do differently if there are teeth. I just didn't want to do that on this one because it would take a long time to create all the individual teeth and make sure they all fit together. So I chose a creature that doesn't. That's why I chose a creature that normally has no teeth. Now I actually did create teeth for the reticulated python when I did the snake, because reticulated pythons are a snake that does have teeth. But I actually made those a separate conformer because I wanted the snake to be able to be both like a ball python, which has no teeth, and a reticulated python, which has lots of teeth. So I made the teeth a separate conformer so that you could just conform them to the jaw area. And in that case, the teeth were still rigged with the upper and lower jaw. They just were fitted to the figure instead of part of the base figure. So that reminded me that I actually have sort of done teeth before. I did them as a conformer instead of as part of the base figure. That just about wraps us up. We're ready to, at this point, you've got your character, you have a bone rig, you have a weight rig, you have weight maps, you have some morphs, you have controls to close the eyes, move the tail around, etc. We've talked about using geometry substitution to work in the mouth area. We've talked about adjusting your joints and maps. And we talked about dealing with things like eyes and teeth. Is there anything here at the end that we don't understand or that you would like to have clarified?
Yeah, thank you for the variety of questions that we've had today as well.
Yes, really good questions today, you guys. You're a good group.